Hello everyone, this is a US car. It has no power, so that's what the customer bring it in. It's already plugged to the power. The switch here is on, but we have no display, completely dead. So before you do anything, check the fuse. Yeah, the fuse looks good. Yep, the fuse is good. So let's check next. Alright, let's check the output. Yeah, no voltage. No voltage. Yep, no voltage here. We have 110, 120 coming to here. So there is something wrong with the power supply. Let's check it. So this is the power supply after we remove it from the case. Yeah, this power supply has one transformer and the multi output. Yeah, it's look like it's a little bit not very simple power supply and not very complex power supply, because it has these resistors, it has many stuff here that make it is not simple. So there's some ICs here, like the regulators. Anyway, let's see if we can understand how this power supply works, so we can try to fix it. Already plugged this wire, because I can't take the wire from the car. So this is the input of the 110. So let's go to this fuse, check step by step. Is the fuse good? Yep, the fuse good. We have these filter coils, and it's go to the input of the rectifier bridge to the metal ones. This is the ground. We are not worried about it. Even if it's not connected, it should be okay. And this is the live and the neutral wire. So all the way to the rectifier bridge, it's good. So let's go from these two wires. Let's go one fuse. Let's go to this varistor. Another varistor here, or this is a capacitor. Then we have a coil, some capacitors, another capacitor, and the rectifier bridge. So we have to do just to check if there is a connection from here all the way to the input of the rectifier bridge is good. Then from here all the way to here it should be good. Alright, is there any short in the output of the rectifier bridge? No, we don't have a short. So we're testing with the diode mode, because sometimes this IC here it's go short, and that's my but usually when this one is get short, the IC is gonna burn and the fuse is gonna go open. Alright, let's just plug it and see first if we have voltage. Sure, we're gonna have the voltage in this big capacitor, so we know all this section here is good. Then we're gonna go to this section here between the should be, this is a MOSFET, this is a switching IC. between switching IC and MOSFET to see if we have all the voltage, we have the signal. If we have everything okay here, then we go to the output section, this part here. So checking the power supply is a 3 section. This is 110 inputs all the way to the rectifier bridge to the capacitor. Then this section is switching section between the MOSFETs and the switching IC and the optocoupler. The output section is here. They have the diodes and filter capacitor and some regulators. And we're going to check one section by section to figure out where the problem. So let me plug it in. So just we want to be sure that nothing is going to explode. Okay, so this LED is off. This means there is no power. And let's go to the AC mode here. The white and black, it should be 110 or 120 volt. Let's go the high speed. $110 and $120 should be here. Okay, that's good. So to the input of the rectifier bridge, that's where the EC stop. Now we're going to switch to the DC for this power supply. Some power supplies, they may have some AC's output. If the rectifier bridge works good, we're going to have like 160 here or 170. So that's good. So that's going to go to the capacitor, and from there it's go to the all around. This section is good. So we test it, all the voltage coming to the capacitor 170. Now we go to the switching part, this one here. For the switching part, we're going to check the VCC that's coming to this IC. To make this IC work, it will need the VCC voltage. 2 voltages making this IC work. Voltage start and the VCC. To check the voltage, the VCC voltage in this IC, we can look a capacitor like this one and a diode next to it. So this is the diode and this is the capacitor. So let's go to, we're going to use the negative side of the big capacitor as a ground, and we check the output of this diode. We have 12, 13, 15 volt. When the voltage, we see it moving like this is a voltage start. This is not a stable voltage. It's not mean there is a short, but the voltage start is came like that. Okay, let's see where the voltage start come from. Okay, this is the capacitor. Yeah, this side of the transformer, this is the VCC. What's the part of the transformer that's making VCC, and this is the main current part of the power supply. Alright, so we have this big traces go to here. I think there should be a resistors. Yeah, we have one resistor here, one here. So from this resistor, from here it's go to here by this resistor. It's a big resistor, it should be like mega ohm. Then it's go to here, it's go to here, and it's go to this point. What that point is, from this point we have another big resistor, mega ohm resistor, to here to the rectifier bridge. So that's what is our startup voltage. The startup voltage, it will be taken from the EC side, not from the DC side. This is the DC side, the positive and negative of the rectifier bridge. This is the EC side, and you can see this side is connected all the way to here. So we have voltage start coming all the way to here, but I don't think we have the VCC. We have some diodes right here, I'm not sure about them. This resistor is for the IC, with all this stuff here. Let's start checking that diode. At the moment, I'm a little bit sure the problem here because we don't have the VCC that's going to the IC. The voltage start is just giving the first volt for the IC to cut the first cut. The first cut, it's going to send the transformer. The transformer here, it has two coils, the main coil and the VCC coil. The main coil is here, and this is the VCC coil. I don't think this pin is connected to anything. It is going inside the transformer, but it doesn't look like anything soldered to it. Yeah, the pin is not connected to nothing, this one. So this is a VCC coil, this is the main coil. The first cut of the IC, it will send the signal to the MOSFET. It will cut the voltage for the first time. The transformer, it will start for the first switch. And that's going to give the signal to the VCC. The VCC is going to go to the IC. The IC is start getting the voltage from the VCC and keep going like that. But if we don't have the voltage start, the IC is not going to work. At the moment we have the voltage start, but we don't have the VCC. If we don't have the VCC, there is something wrong with the IC, something wrong with this MOSFET, or could be the diode that's filtering the IC, filtering the signal, the VCC voltage. It could be many things, but let's alright, I unplug the power supply. Let me discharge that weak capacitor using the solder iron. I need to short it for a while, short it for like 1 or 2 minutes till you be sure completely the capacitor discharged. Alright, what's the voltage in the capacitor now? It is a 0.3 volt. And you will see the capacitor start raising the voltage again. That's why you need to short it for a little bit. If you short it quick, the voltage is going to come back high again. Now you can see it is almost 1 volt now. It's going up. That's good enough. Okay, let's check the MOSFET. If there is any short, I'm kind of positive about that. Shouldn't be there is no short in the MOSFET. Point four. Here it tested very low. see how many ohm. Is a 1 ohm between, okay, this is, yeah, this is the drain because it's going to the transformer. This is should be the should be the source with the low ohm resistor. This one here should be like less than 1 ohm. So from the negative, the capacitor, let's go to here, then we have a low ohm resistor, then it's go to the source, and this is, should be the gate. So to have 1 ohm between the gate and the source, that's bad. Like the gate is not connected direct to the IC. Still there is a chance could be the IC still good, because between the gate we have this. Let's go to here, to this one, we have these resistors. They go to here, then we have another resistor from here to here, and we have another one here. So maybe this resistor is going to save the IC from having the high voltage from the source. So let's start checking these ICs or these resistors. This should be like a 10. Should be 10 kilo ohm. Is a brown 1 0 and 3 zeros. The orange is 3. So it means 10 kilo ohm should be here. So this diode must be bad. This diode here should be bad. This diode is a 51 ohm. Yeah, 51 ohm is low. No, it should be okay, because this is 5, 1, 51 ohm here. 5, 1, 51 ohms. So this one should be okay. This one 400 ohm. This should be like 22 ohm. But this is shouldn't be like, because it has the yellow. 400 is kind of low here. So let me remove that diode. Alright, this diode is bad. Definitely this diode is bad. So let's check the resistor next to it. Yep, 10 kilo ohm. 50 ohm. Yeah, we're gonna remove this diode as well. Just one side of it with this switch. Yeah, look like this diode is good. So 0.5, and if we flip, open. So the diode is good. Next one is this resistor here. It is very low. Alright, now we are going to check if we have the wave, the signal from the switching IC. and this is the gate of the MOSFET. You already start seeing the wave. You see that signal? Yeah, so the IC is making the wave. Yeah, that's the wave. Alright, we have the wave is about like 15 volt, and these are 43 hertz. So that's telling us the IC is making the wave for the MOSFET. I think if we change that MOSFET and we change this diode, it should be good to go. Well, let me try to find something similar to that one. So this is the MOSFET we need, is 12N60NZ. 12N60NZ. So that's the MOSFET. Is a 12 amp 600 volt, and we have gate, drain, and source. This is what I do have here, and setup is the same. The gate, the drain, and the source. This one doesn't have the double diodes here. This one has double diode, the other one doesn't have the diode. So Y is the same, it's a 600 volt, 12 amp. And I'm going to check it from this point. And we need a diode. I don't think this diode is matter, because this is just like for protection. Even if we don't put it, it's okay. We still have the wave going to the MOSFET. Check this diode. The diode is good, and the MOSFET is good. So now is the moment of the truth. Let's test it. Alright, let's test it. Yeah, just get ready for anything to explode. Okay, that's good. So nothing explode, but the LED light is not on. No, still not on. Do we have any voltages in the output? No voltages. No voltages here. How much we have in the capacitor? 160. Yeah, that's the positive is going from the rectifier bridge to the capacitor to the transformer, and the negative is go to that resistor and go to the drain or the source. Yeah, the source we have source we need 160 in the source. Yeah, we have 160 in the source. Should start carrying now. Yeah, no voltage in the drain. We don't have the voltage start. It's a 0. Remember before we have like 12 volt here. What's going on? Alright, it didn't work. So it could be the IC is getting weak. Because when we check the first MOSFET, it was shorted between here to the gauge. And that's the negative side to the gauge. So I removed the MOSFET and we don't have the short here. But I do have a short in the VCC line. This one here, 23 ohm. Two ohm in the VCC. This means the IC is bad. There is something we can do, something else. And let me show you some change we are going to do to this board to make it works. Because I'm a little bit sure this side of the board is good, this side, the switch inside is bad. The AC input is good as well. Most of the time the aftercoupler is still okay. So what we're gonna do, we're gonna replace the switch input. This normal, this ICs, they go bad. Sometimes you test everything looks okay, but still the board doesn't work. Alright, this is the IC. We still have the short. So the VCC, it's right here. No, we don't have the short. So the short and the IC. This is the component, but they were bad. You did see that we did test it with the oscilloscope and the IC was working, but now it doesn't work. I'm going to use this one to do some modification. This one here. This is a switching board. The switching IC plus the MOSFET. And I'll show you how we're gonna do it. Now this one it came with no paper, and that's why I make this one. There is another model. This is big ones. I use them for the TVs, the big TVs, because the MOSFET is big. Yeah, this one is between 24 volt and 12 volt. You switch the resistors. like here, you switch this resistor to here, it will be 12 volt or it will be 24 volt. This resistor here. For me, I'm not sure about the output, what it's here, could be like 35 volt, 45 or 18 volt. So I want to use the optocoupler from this one. The other one, it has their own optocoupler. Yeah, you see it, that's the optocoupler. So let's start putting it. And we're going to need to check something. Always with this one, you check where is the ground for the optocoupler. So this part is the bottom side of the board. The ground, it should be here. Should be this one is the ground. Negative side of the capacitor. Is this the ground? No, that's not the ground. So we are going to need to do a modification in this optocoupler. Make this side ground, and we connect this side to the white wire to make this one work in this board. So always check if you have the optocoupler one side connected to the ground. For that, I'm gonna remove, you can see that's the side should be connected to the ground. We have something right here is a resistor. I'm going to remove this resistor and remove this one here is a resistor as well. When you want to use this one, always remove the MOSFET and the switching IC if you can. But you need to remove the MOSFET. So just one side of these resistors. And we keep them here in case of the customer want to, do anything on this board, or next technician want to work on this board is going to know what's going on. We need this one. That's the ground side. So we're going to connect the ground side to the negative side, like the optocoupler to the negative side of this one. Right now we have our ground is good. This side of the optocoupler is gonna connect to the feedback, but we're gonna need to remove our resistors over there. So this is what we have over there. Yeah, we have nothing here, I think. Yep, we have nothing over there, but we have one resistor over there. Let's take that resistor out. The white will be connected to the feedback of the optocoupler. See this side, let's go here and let's go here. Let's go to this point, but we did remove the IC, nothing over there. The white cord is connected to here. This is the one. The yellow, it's go to the drain. So the drain is the middle side of the capacitor of the MOSFET. Just like that. Yellow is the drain. The black is go to G and D. Let's mean to the. I can put it in this point because we have the wire. It's going through here. Okay, connected with it. Or it's better to connect it from here. So G and D is good. The VCC is the red, and that's the point where is the VCC. This one here, that's the VCC.
All of these boards.
Mm-hmm. Alright, the VCC is good. I would like to, I'm gonna move this feedback. I'm gonna try to do all the wires here by the IC holes. It's gonna make them look better. So feedback, let's go to this hole.
Someone sent you, well, screws, I don't know, parts loose. You know that guy?
No. and the green one, it's go to the positive side of the capacitor. This one, the positive side of the capacitor. Okay, positive side of the capacitor. I don't like to put too much pressure on this little tiny wire here. That's why I'm gonna move the ground. To here. So to be safe. Right. So all the wires is one side. That's good. This board, it has the voltage start, and it came from this green wire, the positive side of the capacitor, and there is a two big value of the capacitor, two big value of the resistor. And that's two, these two resistors right here, that's for the voltage start. So we don't need the voltage start from here, and for that reason we're going to need to remove this resistor. We just will remove one side. That's all we need. So all the other components, that's we should remove them. It's already removed, and look like everything is connected right. So I plug it to the power. Nothing explode. Look over there. You see the green light? It works. Yes, it works. Okay, the G, I think that G should be the ground. G to V, we have V4, 14 volt, we have some output. There is V3, no voltage. I think this one wasn't connected. And we have another G1, V1, 29 volt, sounds right. V2, 5 volt for the standby. It works. We don't forget this thermal pad, and this is like, because this is a metal, you shouldn't touch this one metal. That's why they put the pad over there. over it. It works now. So that's all for this video. Thank you for watching and see you again.